Tonight's event is part of Exploration, the Globe and Beyond. Exploration is a Monroe lecture series normally sponsored by the Humanities and Social Sciences at Caltech. This year, we're really lucky to be teaming up with the Keck Institute for Space Studies. Thomas Prince, Michelle Judd, and their KISS staff have provided indispensable insight and support to make this event happen. I also want to thank our chair, Jean-Laurent Rosenthal, for his wonderful support, and our amazing staff in HSS, particularly Fran Theis and Kapawi Stibbard. It is my great honor and joy to introduce Dr. Rosaly Lopes, Senior Research Scientist and Director for Planetary Science at the Jet Propulsion Laboratory. Our lecture series was created to bring together a broad community, scientists, engineers, social scientists, humanists, artists, and the general public around the topic of exploration, all the way from antiquity to the present. Caltech's founding generation dreamed of a research institute populated by world-class scientists and engineers with a broad vision, able to risk standing outside of their fields, indeed to span many fields, even to reinvent themselves in the risky quest to answer pressing questions about our world and ourselves. Dr. Lopes is a scientist and explorer who has crossed countless boundaries in the quest to explain not only the geological forces that govern life and death on our planet, but those internal forces that move alien worlds as well. And she bears a special gift for conveying to a very diverse audience the thrill, the scope, and the implications of her vanguard science. Nearly 5 centuries ago, in the year 1519, the unflinching war wizard Hernán Cortés found himself marveling at Mexico's natural wonders. On his way to the Valley of Mexico, where he hoped to meet Emperor Moctezuma, Cortés rode over the pass separating 2 now famous volcanoes just south of the Aztec capital, the smoking mountain that we know today as Popocatépetl, and in Aztec lore, its lover, Iztaccíhuatl. In his letter to Charles V, Cortés recounts how he paused his march on Tenochtitlan to send a reconnaissance party to discover the secret of Popocatépetl's smoky caldera. When the party returned, hauling large samples of melting snow and icicles, Cortés thought it was a great novelty to have found a smoldering volcano covered with snow in the middle of August and on a tropical latitude of merely 20 degrees. One almost wishes that Cortés would have been diverted from his purpose and might have instead aspired to solve the mystery of fire and ice in latitudes that Europeans had originally thought would be so torrid as to be hostile to all life. Instead, Cortés had to disappoint us all by conquering Mexico City. But the wonder that Cortés felt as he regarded the icy prize that was brought back to him from the fiery mountains that gated Montezuma's empire was fortunately shared and cultivated by other Europeans. These naturalists set out to unlock the natural mysteries of a brave new world that they had never imagined. And in the process, they forged the early stirrings of a scientific revolution. 5 centuries later, we are witnessing another revolution at the threshold between our world and alien worlds. And leading that revolution is a scientist who has unlocked the mystery of fire and ice, and whose written work conveys the wonder that lies at the heart of exploration and discovery. Among the numerous books that Dr. Lopes has written, I've been reading through the pages of her Volcano Adventure Guide, which was published by Cambridge University Press in 2005. Explaining why we should care to visit what many consider the scariest, smelliest places on Earth, Dr. Lopes writes, "Active volcanoes are the ultimate adventure destination. Those who have been lucky enough to witness a fire mountain spouting red lava high into the sky or billowing clouds of steam rising as lava pours into the ocean will testify that volcanoes provide one of nature's most awesome spectacles. Volcanoes are impressive, spectacular, and have a profound effect on life on Earth. A trip to a volcano is a challenge to the mind because it gives us the opportunity to see a major geologic process at work. Volcanoes deepen our understanding of how the Earth evolves and how humans interact with nature's forces. Volcanoes are magnificent in repose and thrilling in action when they allow us to experience the sounds and sights of nature at work. Volcanoes appeal to our intellect, our appreciation of natural wonders, and our fascination with danger. Only a few pages into Dr. Lopes's adventure guide, one suddenly realizes that volcanoes, Dr. Lopes's volcanoes, like the Aztec deities Popocatépetl and Iztaccíhuatl, have come to life in one's mind and heart like any other life form in our world, but that, unlike any other creature, they wield the key to life and death over everything else. One of the many lessons Dr. Lopes teaches us with her work is that this wonder that seizes mind and body is the wonder that leads to discovery. That discovery leads to understanding, and that understanding leads to innovation that may enable us to live in harmony with the changing world around us. We are fiercely proud to have her with us tonight. I leave you now with Dr. Thomas Prince, Professor of Physics in the Division of Physics, Mathematics, and Astronomy, Senior Research Scientist at JPL, and Director of the Keck Institute for Space Studies. Tom will speak more specifically to Dr. Lopes's achievements as a volcanologist and planetary scientist. Thank you.
Thank you, Nico. I think it's quintessential Caltech that we can have the Division for Humanities and Social Sciences coordinating with the Keck Institute of Space Studies, which is a highly technical organization, to bring together the humanities and the sciences in exploration and really fuse those together. I'll say a few things about Rosaly Lopes. I've had the pleasure just in the last few months of beginning to work with Rosaly. I had not done that before, and getting to know her. And so I'm especially pleased to introduce her to you today. She has many fascinating aspects. She is a senior research scientist, which I think is on here someplace, right there. At JPL, and that's the highest title of any scientist at the Jet Propulsion Laboratory. She's also the manager of the Planetary Sciences section at the Jet Propulsion Laboratory. A little bit about her research. Her research is about geology and volcanism, but very specifically, two areas. One is volcanism on Io, that's a moon of Jupiter, and if you don't know what it looks like, it's right there. That's Io, and she'll undoubtedly be talking about Io and the volcanoes there. Those are hot volcanoes. She also studies cryovolcanism on Titan. Cryo coming from the Greek word icy cold, and so that's where the fire and the ice come from. You have volcanoes of both types. She is author on over 100 publications. I have her CV here. She has very, very many honors and awards. I'll just name a few of them here. She has won the NASA Exceptional Service Award, or Service Medal. She's a fellow of the American Association for the Advancement of Science. She is winner of the Carl Sagan Medal of the American Astronomical Society for Excellence in Public Communication in Planetary Science. That's quite an award. She has many tidbits in her CV. Another award that she has received is the Angel Award for Outreach Efforts in Morocco. Interesting. An award relevant to today's talk is that she is listed in the Guinness Book of World Records. And do you know what for? She is the person who has discovered the most active volcanoes of anyone. Okay, and I won't tell you the number. You should try to guess the number, but maybe she'll tell us how many you're up to during your talk. She has been profiled in 10 different books. She is also the author or editor of 7 different books. One of them was mentioned, actually 2 of them were mentioned here, but I'll just read you a couple of the titles. First of all, she is co-editor on Volcanic Worlds, Exploring the Solar System Volcanoes, forward by Sally Ride. Probably some of you have heard of Sally Ride. She's co-author on a book, Alien Volcanoes, forward by Arthur C. Clarke. probably heard of R.C. Clarke. She runs in interesting circles here. She's co-editor of a book, companion book to Alien Volcanoes. It's called Alien Seas. It's a foreword by James Cameron of Titanic fame, and also a person who's done a documentary called Aliens of the Deep, which has a relationship to hydrothermal vents and volcanism under the oceans. So all of this ties together. She's co-editor of the graduate level book, Modeling Volcanic Processes, The Physics and Mathematics of Volcanoes. She's sole author on an undergraduate text that's just simply entitled Volcanoes. And lastly, she's the author of the book that Nico mentioned, the Volcano Adventure Guide, which is also, if you would rather read it in Portuguese, it's been translated into Portuguese as well. So I hope you get a feel that this is a fascinating person. I have not heard her ever speak, so I'm particularly delighted to hear her. And so please, Rosaly, she will be talking on fire and ice, exploring volcanoes on Earth and the solar system. Rosaly.
Thank you. Thank you, Plinian. Thank you so much, Nicholas and Tom and Michelle, for inviting me to speak here. It's really a great honor, particularly given that we are in the Robert Sharp lecture hall. And for those of you who don't know, Robert Sharp was a really famous professor of geology, one of the great American geologists. So this is going to be about fire and ice, exploring the volcanoes of the solar system. And I'm going to start by, mainly speaking about the volcanoes on Earth, because as my PhD advisor told me, you can't understand volcanoes on other planets without understanding volcanoes on Earth. And then I'm going to take you to Io and Enceladus, and on the way there's a little nod to Mars. So this photo was taken at the Yazur volcano on Tana Island in Vanuatu. And we're going to see some more of Vanuatu later. Most people have never heard of Vanuatu, but in fact is got two islands with active volcanoes that are absolutely spectacular and in fact fairly easy to visit. And this is called Strombolian activity, and we'll see that later. And that picture was taken by a friend of mine who actually had remarked that I have never seen a picture of you with a volcano exploding behind your back. And so when I posed for that picture, I realized that in fact it's really very uncomfortable to have a volcano behind your back without looking at it. So there was a reason. So volcanoes are in fact found in many places in the solar system. This is from the photojournal website, just a representation of the sun and the planets without Pluto, because Pluto is no longer a planet. But we see volcanoes or signs of past volcanic activity in many, many places in the solar system. And here is a fire fountain in Hawaii on Kilauea. It's about 30 meters high, and it's one of the most beautiful things you can see, is what we call a lava fountain or a fire fountain, to be a little bit more romantic. So, we study volcanoes on Earth in order to understand this whole very complex process of volcanism that, I'm not going to attempt to explain everything, but just touch on a few things. But first of all, something that's important to know is that the surfaces of the solid bodies in the solar system appear different because they are formed by an interplay of the major geologic processes. We have volcanism, we have impact cratering. This is meteor crater in Arizona. We have tectonism, and we have erosion. So on Earth, we have a lot of erosion. We have plate tectonics that's destroying old surfaces. We have erosion by wind, by water. While on the Moon, there is no erosion except by, micro meteorites these days. So when you look at surfaces of the different solid bodies, you're really looking at that interplay of these major processes. And that's why the surface of the Earth is, let's say, so unique. We have plate tectonics on the Earth, we have large quantities of water, and of course we have an atmosphere that you don't find dense atmospheres in many places in the solar system. So going on to volcanoes on Earth, where are they? I have worked quite a bit with Michael Carroll, who is a space artist, and he did this nice representation of the tectonic plates. If you want a more textbook one, here's the mid-Atlantic ridge, where the plates are spreading apart and magma is coming up. And in fact, you have all these volcanic islands like Iceland and many others along here. Where the plates are converging, you get mostly different types of volcanoes, such as on the Andes, and here the Cascade volcanoes in Alaska, and this is of course called the Ring of Fire around the Pacific. Philippines, Indonesia, those places are just riddled with volcanoes. So it's very exciting for us volcanologists. It's not so exciting for the people who live there. And we have some volcanoes in the middle of plates, such as Hawaii. That's volcanoes atop a hot spot, and also in places in Africa. So we have different types of volcanoes, but mostly on Earth, you can trace them to the mid-Atlantic ridge or the mid-ocean ridges or the subduction zones. Most volcanoes on Earth are actually found under the ocean. This is a picture of the East Pacific Rise. And these are called the Black Smokers, and that's what James Cameron did that documentary about. And they became very important for biologists because you actually find a lot of life. These I think are kind of little crabs. I'm not a biologist or astrobiologist, but these are very exciting places for people who study how life evolved. And occasionally when volcanoes build up and build up and build up and breach the surface, they can form new islands. So for example, all the Hawaiian Islands were formed that way. And this is Surtsey, 1963. This image was taken by my late advisor, the Professor John Guest, who actually went to see this eruption. And so Surtsey was this new island that came up in the early 1960s. It's still there. It's actually also a place of great interest to biologists because they have kept this island very pristine and studied how birds stopped there and how life actually started on this island. I'm going to let you know this couple of diagrams about different types of volcanic eruptions. In fact, this classification of with names of volcanic eruptions was done by Giuseppe Mercalli, an Italian who in fact also did an earthquake scale, but not the Richter scale, which we mostly use, but a scale that I understand is still used in engineering about the damage of earthquakes. But he classified different types of volcanic eruptions according to how explosive they are. And so I'll give you a little tour of some of the volcanoes with these types of eruptions. And they're not, it's not a very scientific classification, but on the other hand, it's useful. If you ask me, oh, let's go and see this volcano that's having a Hawaiian eruption, I would say sure, but if you ask me to get close to a Plinian eruption, I would say forget it. So it's important to know the main types. This, for example, is Merapi in Indonesia, which is a very explosive volcano. So depending on the predominant type of eruption that volcanoes have, you actually get different shapes. You get some shield volcanoes that are like the Hawaiian or Icelandic volcanoes, formed by this type of eruptions, which are mostly lava flows. And you can get some stratovolcanoes, which are the classic cone shape, like Mount Fuji, and they're formed by a lot of explosive activity, as well as some lava flows. But what causes some volcanoes to be so different from one another? And it's mainly actually the type of rock. What causes a really dangerous explosive eruption as opposed to a really mild Hawaiian eruption that you can, go right up to it? It's mostly two things. One is the type of magma, and the other is the amount of gas in the magma. So if you think about, some people say a can of soda, but I prefer a bottle of champagne. You shake it, and the pressure builds up, and it sort of eventually blows up. Well, those are the explosive volcanoes. So this type of lavas, dacite, andesite, rhyolite, from here to there, they get more and more SiO2, if you want to get scientific. That's something that forms very strong bonds. So it's very difficult for the gas to come out when you have those strong bonds. While in basaltic lava, it just bubbles out. Now, in the other hand, so when the magma is coming up, the pressure becomes less, and this gas wants to come out. So it can either come out easily, because the rock's not very sticky, or it can really, the pressure can build up, and eventually it just explodes, and the magma turns to ash. Now, if you have very little gas in the magma, then it's not going to explode. And in fact, we have some flows of this very sticky magmas that we nickname toothpaste lava, because they just come out like toothpaste. So that's, in a nutshell, the very basic thing is the how viscous the lava is, or the magma is the lava when it's underground. Lava is magma once it's on the ground. So how viscous it is and how much gas it has. So going on to some of the illustrate different types. Well, Yellowstone, many of you I'm sure have visited, and we have these geysers and hot pools, which are great to visit, except Yellowstone is actually the largest caldera on Earth, formed by absolutely cataclysmic eruptions, but luckily over 600,000 years ago. And the chances of it erupting again like that are relatively small. There is a very large magma chamber under this caldera, and recently another magma chamber was discovered lower down by someone a group analyzing lots and lots of seismic data. It doesn't actually increase the danger that is going to erupt, but Yellowstone is a large caldera on Earth. And by the way, the reason they suspected this unknown magma chamber was under there was that Yellowstone put actually a lot more CO2 than you would expect from this more shallow magma reservoir. But on the whole, Yellowstone you can visit very easily, and there is no danger. Well, if you obey the signs. Believe it or not, someone died in Yellowstone because this guy decided to scuba dive in one of the hot pools. Not a good idea. So I'm not sure what he thought he would learn. So very spectacular activity is Hawaiian and also Icelandic activity. They're kind of cousins, formed by low viscosity lava that erupts mostly as lava flows. Here you see a Kilauea lava flows entering the ocean, and a lava lake. This was actually taken at the end of April, so this is quite recent. This is in the main Kilauea caldera, and with a lava flow spilling over. And this is in Iceland, is Eyjafjallajökull. I can't pronounce the Mexican volcanoes very well, but I learned to pronounce the Icelandic one. And this is the one that actually caused all the trouble a few years ago and left people stranded in Europe. It was not actually a large eruption as volcanic eruptions go, but it actually was very explosive because meltwater from glaciers actually got mixed in, and so it created a lot of ash. And the wind was blowing just in the wrong direction, predominant winds, so it caused a lot of trouble in Europe. And this is Krafla in Iceland in the 1980s, and this is a view from above. So you're seeing this row of fire fountains here on a fissure. A long fissure with fire fountains is very typical of an Icelandic eruption, and then lava flows coming out. These Hawaiian and Icelandic eruptions are the most beautiful that you can see, and lucky for us, they're also the safest. And they do create some trouble in Hawaii, you know. For example, you can pick up some cheap property, and there are people who still live in these houses, and they call themselves lava people, and they are very proud of it. Actually, it's a bit of a hippie community. The roads can be a bit of a problem. And they need to be rebuilt often, and where you park your car can also be a bit of a problem. These eruptions are actually very safe to go visit and watch because of this lava flows are not very dangerous. In fact, this is one of my favorite activities, and in fact, if you are in Hawaii with a film crew, they want you to go poke at the lava with your hammer and get a bit of lava out. And so this flows, even the part I'm standing on, it's still got hot lava underneath. But as long as the crust cools very quickly and is a very good insulator, so it actually as long as the crust is kind of thick enough, you're safe actually walking on lava. So you may not be able to walk on water, but walking on this type of lava, it's not actually very difficult. And if your boots start to smell, then it's time to move. And this is just getting as close as the boots can stand it. And my boots don't tend to last very long. Sometimes you might be walking over lava tubes and you might not even realize it because this guy is quite safe. There is it's quite thick here, but lava, one of the reasons that lavas in Hawaii can flow for such long distances is that the top cools, forms this insulating layer, and then you get the lava tube underneath, and the lava is really well insulated. So it carries on running. And many of you, I'm sure, who have been in Hawaii, you might have visited some of the lava tubes there, the old lava tubes that you can actually visit. And just a little nod to Mars, because Bethany is here. This is Olympus Mons, a shield volcano. Similar to the shield volcanoes in Hawaii, this is a Circe image of Mauna Loa, so you have a rift zone here, very well defined, and this very long lava flows. This has some vertical exaggeration, but Olympus Mons is a shield volcano, and it actually was formed by very, very long lava flows. And it was actually the first volcano I studied, so I'm kind of fond of it. It's 26 kilometers high and about 600 kilometers in diameter, so it's also the largest volcano in the solar system. Nothing like starting with the largest, and it has this material here, lots of deposits of this corrugated material called the Oreo material, and that was one of the topics of my PhD thesis. Next type of activity is Strombolian, and there may be a few people here old enough to remember that movie. Stromboli, which is actually, I didn't find it a very exciting movie. It's a black and white movie of a type called cinéma vérité, so it moves very slowly, but this, I think, is the best movie poster of all time. It says, some of them say Raging Island, Raging Passions. So it's really good. Stromboli is, these Strombolian eruptions are also great to watch. The lava is a bit more viscous than in Hawaiian eruptions. They might form shorter and stubbier lava flows. But you get these discrete eruptions. Instead of a fire fountain that's continuously whooshing out, you get one explosion and all these fireworks go up, and then you might get 30 seconds or even 30 minutes, and then another one happens. So that's the group I went with to Stromboli, and we're viewing the crater here from a very safe distance. But this is also what happens in Vanuatu. And in the US, an old example is Sunset Crater that erupted between 1064 and 1250. And this is a recent one on Mount Etna. Sunset Crater actually, it's quite interesting from an archaeological point of view because these are the Wupatki ruins. Native Americans lived there. They became known as the Sinagua tribe. Sinagua means without water, so that's like us here, except for today. And they, there are no bodies found in this region, that no people were killed because of the eruption. They start out small, and this cone builds up and builds up, so they had plenty of time to get away, and they got away, and eventually, after the end of the eruption, they came back, and in fact, you know, the evidence the archaeologists found, not only they came back, but because volcanic ash can make the soil very fertile, they actually thrived. And this is supposedly the first population explosion in the US, because they really did well from these volcanic eruptions. And so to talk more about Strombolian eruptions, I'll take you to Vanuatu. I've been there a couple of times. And this island here called Tana, it's the one of the title slide, has this beautiful volcano called the Azure. And something else about Strombolian activity is that it goes on for a very long time. Stromboli has been active for at least 2,500 years. And they may stop for a short time, but in general, they keep going. So Tana, the records, of course, are not as good, but it's been active for a couple hundred years at least. And this is the volcano, and I was there last year with a TV crew, and you can see here one of the natives very interested in the camera. And one of the nice things about field work is to get to know the people. And in this case, our guide actually knew the people in this tribe very well, so they, you know, put a dance on for us, and you know that they are dancing, and they're very, very friendly. They mostly want to know three things: where are you from? Fair enough. How many kids do you have? And they were a little shocked that of our group of 5 volcanologists, I was the only one with a kid, and I only have one. And then, what religion are you? Those are the 3 questions you always get asked. And they also started pulling my hair, you know, the kids, and the guide explained that they don't see blondes very often. So. And this is a photo taken from an airplane. In fact, a few photos. This is with an infrared camera on the way back. The flights between the islands are on small planes, which are mostly piloted by Australian cowboy pilots. And one of them got to know us, and you know, as we were about to leave, he said, Of course, there's no door to the cabin. And he said, well, what would you like to see? And I said, oh, can we go around the volcano? And he said, sure, it's not on our flight path, but, we can do it. And he said, well, when we get there, just get up and come here to the cockpit, and we'll open the window, and you can take pictures. So that was great, It's it's like I'm a frequent flyer on United, and they don't do that for me. So that is a Strombolian activity. I see that we don't have sound here, but anyway, that's what happens. That's from one of those vents. So you have these pieces of lava, we call them bombs. They don't explode, but it's broken up chunks of lava. So very, very beautiful eruptions to watch. As we get to Vulcanian eruptions, they get more dangerous. Volcano is actually a neighbor of Stromboli. They are both in the Aeolian Sea in Italy. And Volcano gave its name to all of the world's volcanoes. This was thought by the Greeks and the Romans to be where the god Vulcan actually had his forge. The volcano has not been active since the late 1800s. Not with a major explosion. These days you get a lot of fumarolic activity, but it's these eruptions much more explosive and more dangerous. This is one on Mount Etna in the 90s, and you can see one of my colleagues here deciding that he was probably too close and you better come away. And the bombs that you get out of these eruptions can be pretty large. So you realize you don't really want to be in the path of one of those. And they can have some lava flows. They are usually short and stubby lava flows because the lava is more viscous. It can still be basalt, but it will be a more viscous basalt. And there is an example of a Vulcanian eruption here. This is the volcano Tavurvur in Papua New Guinea. It's part of the Rabaul caldera. This video is actually in the internet on YouTube, but you see here the explosion and you see the shock wave. And if you unfortunately we don't have sound here for whatever reason, but so this type of eruption, you better be a fair distance away. And then as we get more explosive, we go to Pelléan eruptions named after Mont Pelée, Martinique, 1902. This eruption killed about 28,000 people. And this is the devastation in a photograph at the time. This is the volcano today. And this is a prison cell because the only person who survived in the main part of the city was a guy who was in prison. He was called Auguste Siparis, and he was a black man in prison for killing a white guy. And he was badly burned, but he survived and came to the US and spent the rest of his life with the Barnum and Bailey Circus as the prisoner of Saint-Pierre. Now, what these eruptions unleash are called pyroclastic flows, and these are just the worst things that a volcano can unleash. And I'm going to show you a picture of one. Here, this is the island of Montserrat, volcano Soufriere Hills. These flows are of hot gas and ash, and they are light enough that they can actually flow over water. But they're very, very deadly, and they can move very fast at like 60 miles an hour or more. So you don't want to be anywhere near the path of one of these flows. This is in 1996. The eruption actually started in 1995. It's still a little bit, going on, but it really devastated all the southern part of the island, and a lot of people, it's an English protectorate, and a lot of people immigrated to England because life here became pretty difficult. That's a helicopter there flying close to the eruption cloud. But those, to me, are the scariest things about volcanoes, are pyroclastic flows. So I don't like working on this type of volcano very much. And I did go to Montserrat in 1996, and this is the Tar River Valley where these pyroclastic flows were coming down, and small flows were still coming down. And the team I was with and I were dropped off by helicopter on this beach that was right at the mouth of this valley, and they said, well, we'll pick you up in 3 hours. And I realized that that was a very dangerous place to be. If one of those flows comes down, you can't even go in the water and escape. When we worked in here, we kept our vehicles on the road, pointing away from the volcano with the keys in the ignition. But the worst type of eruptions are Plinian. This is Mount St Helens in 1980, and I'm sure many of you remember this eruption. It actually killed only 57 people because a large area had been evacuated, but it destroyed about 400 meters of the peak. There was an explosion and a debris avalanche, and then a blast that overtook the avalanche, and this came down with flowing at about 180 miles an hour. It even went over a ridge about 1,000 foot high, because these have tremendous energy. And so those eruptions are the most explosive. They form this stratovolcanoes, or this cone-like volcanoes, as the material comes down and gets deposited, but they are very, very dangerous. Now, one interesting thing is that the red zone on Mount St Helens wasn't quite, it didn't go as far as it should have done, and that's because the volcanologists were expecting the blast to go up and not sideways. But in fact, the volcano did have a tendency to erupt sideways. And if there's this painting by Pelcéan, is in the Royal Ontario Museum, and that shows an eruption, 1874. He was on the Vancouver expedition. That is also this dome actually on the side of the mountain. So sometimes, paintings are also very, very good to illustrate these things. And I think I need to go rather faster here, but this is the most famous of these Plinian eruptions of all time, Vesuvius in 79 AD. And the name comes from Pliny the Elder, who was a general in the Roman Navy, and he was here at Misenum with his nephew, Pliny the Younger. And they saw the eruption cloud, and from deposits, Pliny the Younger's account, because he survived, and the volcanologists who worked there were able to reconstruct this timeline of exactly when these pyroclastic flows happen and when ash flow happened, and so on. And so Pliny the Elder was called to help rescue people, and he went to Stabia over here, and he died there. Probably not as a direct result of the eruption, but more indirect. There was a lot of gas and ash, and apparently he was, according to his nephew, like a not too fit man. So he apparently died of a heart attack. And another very famous, this called Plinian, the really, really big eruption, was on the island of Santorini during the Bronze Age. And this became actually is a great marker of the Bronze Age, because the ash of events, because the ash of this eruption can be found all over the Mediterranean. And there is this city called Akrotiri is the Greek Pompeii, and you can still see the ruins there. And this is also called the Minoan eruption, and it's been linked to everything. The end of the Minoan civilization, the plagues of Egypt, parting of the Red Sea, you name your favorite biblical event of that time, and someone has tried to make a connection. And it's also thought by some that this was the Atlantis described by Plato. But that story of Atlantis came from Egypt via Egyptian priests, and it was about 900 years after the event. So in 900 years, a lot can happen in the oral accounts. And it's, so pinning down the date of the eruption is quite important. And there is still a bit of a disagreement between the scientists and the archaeologists. But it was around that time. So of course, the dates of some of these other events, like the Exodus, are not really well known. So there is a lot of speculation there and many books written about it. And this is a little video of the eruption. It's not very high resolution, but I think it's actually quite good to illustrate what happened. So there was an island in the middle, and no doubt there had been other eruptions that happened there, and this is the huge eruption cloud. It formed a collapsed caldera, mostly submarine caldera, and most of the products of the eruption are actually found under the sea. So there are volcanologists and archaeologists who have done work diving there to try to reconstruct this series of events. And now there is another island that since then has come up, but the eruptions have been very mild. So now that we've seen so much about Earth's volcanoes, let's go to my favorite moon, Io. So Io is also known as the pizza moon because it looks like a pizza. And the discovery of volcanism on Io in 1979, it's really a great event in planetary volcanology because Io is about the size of the Earth's moon. And you know, before then, we didn't actually think that such a small moon could have active volcanoes. You'd think it would have cooled long ago. But in fact, about 2 weeks before the Voyager spacecraft got there, there was a paper published in Science. I call it the best timed paper ever. And it actually predicted that Io might have active volcanoes. And that is by Stampill and colleagues analyzed the orbit of Io around Jupiter and realized that there was this tidal bulge that would face Jupiter, except that there are these other moons further out, Europa and Ganymede, that would distort the bulge towards them, and that would create friction that could keep the interior molten. So they actually said that widespread and recurrent volcanism might occur. And when the Voyager spacecraft got there 2 weeks later, I'm not even sure that I was in London at the time, that issue of Science actually had come to our library, but everyone was like, ooh, ah. So Io has a lot of sulfur dioxide and sulfur on the surface, so that's why it's got these beautiful colors. And on the whole, everywhere that's really dark is where you find volcanic activity. This is a beautiful Galileo image. I worked on the Galileo project. This is a Voyager image. And Lonnie Lane, who is here in the audience, worked on Voyager. This is the Loki plume. It's about 100 kilometers high. And you see here many calderas, volcanic calderas, with still many of these have hot lava. And in fact, one of the instruments on Voyager detected heat from on this area that coincided with enhanced sulfur dioxide. You know, so that was pretty much the case. So with Galileo NIMS, the instrument I worked with, we actually detected a whole load of new volcanoes, and that's how I got in the Guinness Book of World Records. And it was actually because of an English postdoc of mine who knew somebody who worked for Guinness, and he said, oh, you know, he would love this. This is actually a fairly high resolution image compared to a lot that we got. So, but what I did was, you know, compare the spectra in the infrared. If something is hot, you know, it stands out in the infrared. And I had to do a lot of work comparing spectra, but, you know, it wasn't a really difficult thing to do. It was actually a lot of fun. And, you know, it's important to know that Io had much more widespread volcanism than we thought from Voyager. You know, also that the volcanoes are very persistent. A lot of the volcanoes, they were active at the time of Voyager with ground-based observations. We saw some of them in between Voyager and Galileo. We saw them with Galileo. We still see them these days, and actually resolution from the ground is getting better and better. One of the calderas called Loki, the one that I showed you that plume, you know, my friend Michael Caro actually did this painting of what the inside would look like. So you have what's essentially a lava lake with an island here in the middle, and a plume up and more on the northern side. And this is very much what we would imagine it to look like. In fact, you know, I collaborated with Michael Caro on a couple books, and it's been quite interesting to work with an artist because they always ask you what would it look like if you were there, and of course as scientists you kind of wonder, what? You know, I just look at data. But then you have to try to imagine what it would be like, you know, being there. And in one of the you know, work that I did on Io was actually when we could get high resolution on some of these volcanic calderas, like Loki. You know, here is Loki again, and this is a low resolution image. But we actually noticed that the edges were hotter than the interior. And what happens is when you have lava lakes on Earth, such as this one in Hawaii, the crust, as I told you before with the lavas, the crust solidifies quite quickly. But because the material underneath is insulated and it's still molten, it kind of sloshes this crust around like scum on a pond. So you actually get this material, the edges tend to be broken and tend to give you the heat signature. And we found that with a number of volcanoes on Io. And this is an image at night from the camera, again detected this line on one of the volcanoes. So we think that a lot of the volcanoes on Io are lava lakes. Loki caldera, by the way, is 200 kilometers across, is the largest caldera in the solar system. We have another one here. It's actually the most amazingly beautiful, I think. It's about 70 kilometers across, so it's more like Yellowstone size. What we noticed by comparing images with the infrared data is that, you know, the lowest albedo, where it's darkest, those are the hot material where the sulfur dioxide has not deposited yet. And if you look at this caldera, right, all the edges, it looks like someone went around and traced it with a pen. And that's really that crust actually fracturing against the sides. And here we have one side where it actually, the lava solidified and cooled enough for sulfur dioxide to be deposited. That's something else we could measure with NIMS, was sulfur dioxide deposits. A few patches of lava, hot lava still coming up. And here, the side that you have the hot lava. And then these strange greenish flows coming down. And we think this is sulfur from the edge that is melting down and coming down. And in fact, my first collaboration with Michael Caro was a painting of the interior of this caldera. And we had a lot of discussions about, you know, how steep the walls were likely to be, and, you know, and these jets, you know, is this the right angle? And with several colleagues, and but, you know, here is the, you know, sulfur melting from the walls. And I like this painting so much that I bought it, and it's in my office at JPL. So a little bit about lava lakes, and one of the interesting things we want to find out, and I know I'm nearly out of time, is the distribution of hot material on these lava lakes. And actually by comparing the infrared signatures of lakes and flows, we can figure out whether it's likely to be a flow, a lake, a fire fountain, and so on. So back to Ambrym, where there is to Vanuatu, I mean, there is an island called Ambrym, has actually a big caldera formed by a Plinian eruption, this 12 kilometers across. But in one of the pits these days, it has a lava lake, and some of you may recognize Ralph Lauren, Zibby Turtle, and Bob Howell he's from the University of Wyoming. So we trudged to this jungle, but we were rewarded with the sight of this absolutely beautiful lava lake. And the people who were here for the last lecture in this series actually have already seen Maroon, this volcano here in the infrared. It's very, very vigorous. This is probably the most vigorous lava lake on Earth. Lava lakes appear to be very common on Io. They actually are rare on Earth. What time do you want me to stop? It's 5 to 6. I just go on a little bit longer. We also went to a lava lake, Erta Ale, in Ethiopia, in the Danakil region, and that's called the Afar Depression. And it's a very difficult place to travel in because it's close to the border with Eritrea, and there was a war between them, and sometimes there is still some conflict. The tribes who live there are also not terribly friendly, but if you pay them enough, they will actually escort you, and they all carry AK-47s, even the teenage kids, which sometimes is a little worrying. We did have a vehicle saying that we didn't have any guns. Traffic could be a bit bad. I'm not sure what I'm thinking there, but it's like, oh. And this is a really, really difficult region to travel in. But the reward is also that you see some things that you just never see anywhere else, I think. These camel caravans, the first one I saw, I thought this is amazing. And then we kept seeing them. And I thought, what are they all doing? And so our guide actually did take us to the place where they all started. And they actually mine salt in these salt flats. And they cut the salt in blocks and they put them on the camels and they travel by camel. And that's, I suppose, what they did 2,000 years ago, but they're still doing it. So we went to two places. This is the Erta Ale volcano with another beautiful lava lake, and also an area called the Dalal. And I call the Dalal Io on Earth because it's got all these incredible sulfur deposits, and this is really one of the most beautiful places I have ever been to. And it's isolated enough that it's still very pristine, although it does worry me if the natives start being more friendly, and realizing they can make money out of the tourists, then this might become spoiled. But it really reminded us of the colors that you see on Io. On Io you see all these sulfur deposits, greens and yellows and reds, and it's even probably a great place for people who study streamophiles. Here's a lake that is very, very green with some algae bugs. And it's not, as I said, an easy place to travel because it's below sea level. The Dalal is 130 meters below sea level. It has the record for quotes inhabited location on Earth. And really the daytime temperatures were over 100. Nighttime it got a little cooler to the 90s. And National Geographic called it the most cruel place on Earth. And Lonely Planet said that there are appalling roads and ferocious tribes. And in fact, the tribes are not quite as ferocious as they were back in the last century when they just used to kill people who went there. And this is the Erta Ale lava lake, about 120 meters across and just totally spectacular. Maroon is actually over 100 meters down from the main crater, so you were mostly looking at it from quite far up, unless you decide to risk going down on a very dodgy way that our last speaker did. But here is a lot easier. You don't need ropes. You can actually get down to this area by just scrambling down the rocks. And this is a video that we took, and we're standing, right here. We had an infrared camera as well, but this is right at the edge of the lake, and you get this absolutely pulsating, beautiful, these waves of lava that just bubble up. I'm sure that, like me, you could watch this for a long time, but I'm not going to keep us from dinner. So let's go on now to the cold after the hot, and temperatures of lavas like at Erta Ale or Maroon will be over 1,000 Celsius. But we can go to ice volcanism, and I'm just going to tell you a little about Enceladus. Saturn's moon, only 300 miles across, very small, and again, a surprise in the solar system, because we have no equivalent of ice volcanism on Earth. And how would we expect to find ice volcanism? So as we explore other planets, we're just learning things about volcanism that are so different from volcanism on Earth. It's really, they say that travel broadens the mind. Well, space travel, certainly broadens your scientific perspective. Cryovolcanism on Enceladus was suspected before Cassini. Images of Voyager showed it a very high albedo, very bright place, and a ring around Saturn that coincided with Enceladus. We called it the E ring, and in fact, it's material from Enceladus that is feeding this ring. There's another painting by Michael Caro. We had a lot of people weighing in. I sent it on email to the Cassini scientists. Angie Ingersoll, weighing in about the angle of these jets. But Cassini did find that, these jets are coming out, mostly water, with some CO2, some hydrocarbons, some salt. There is a recent detection of silica particles. And one of the very interesting things is that this hot water is actually, coming directly from the ocean, and also is in contact with the hot rock, and we may have it's like a deep sea hydrothermal area. So the potential for life existing on Enceladus and other icy moons that have had some volcanic activity, it's really something amazing. So again, before Galileo found that Europa is also an icy moon with an ocean under it, and Cassini found this at Enceladus, we didn't know about cryovolcanism and its possible connection to life, because if you have water, liquid water, you have heat, you have energy, there is a possibility you might have life. Just ending, but very recent result is that these jets on Enceladus that in fact we thought were discrete jets, but it may actually be a curtain from a fissure continuously erupting, and actually somewhat similar to the Icelandic eruptions where you have this curtain of lava, but in this case the magma is actually water with some other constituents, but it's liquid water. So when we're talking about volcanism, we're talking about the process that brings material from the interior to the surface, but you have to define it according to what the magma is for that body. and the magma for Enceladus and Europa, for example, and Titan, the magma is water. So what about the future? What about exoplanets? This is something recent that was in the news. This is an artist's impression, of course, of this exoplanet 55 Cancri E, which is a super Earth, and it's got one side that actually has temperatures in the range 1,000 to 1,200 C, and one side permanently facing the star, and the other side not facing the star. So, it could be that we have like a super Io. And it's very interesting to me to think that just in the length of my career, which, has not been all that long, but we went from not knowing that volcanoes, active volcanoes existed anywhere but on Earth, to knowing that Io is the most volcanically active body in the solar system, to Enceladus with cryovolcanism and Europa and all these icy moons out there that may have cryovolcanoes, and now we're going towards volcanoes on exoplanets. So it's getting really more and more and more interesting, and I just wonder, about 30 years from now, what we're going to know about volcanism. So with that, thank you very much.